Okay, guys, I'm just going to go through the enlargements test. Um, so the first question was handy enough. Scale factor is 1.5. You're given a side of the original shape, PAB, and then you're given the image. So your first question is find QR. Well, if the scale factor is 1.5, you just multiply 6 by 1.5. And the length of QR is 9, because QR is the corresponding side to AB. Now find PB. Well, the length of PR is the image side, and the length of PB is the size in the original shape. So in this case, we're just going to divide, as I've done here. I think you worked that one out yourselves as well. Skipping down along, I guess the last part, find PA, is just a bit of Pythagoras, and then find the area. Just 54, that's a handy enough question, I think. Now, with this one here, one or two you have problems with this. So the scale factor is 0.5, but that's kind of a weird thing about enlargements. The image can end up being smaller than the object if the scale factor is less than 1. But basically here, and in all these kind of ones where you're drawing, you just draw a line from the vertex back to the center of enlargement and do the same for A, B, and C here. And if the scale factor is 0.5, that means the distance from P to B should be double what it was from P to B dashed, or should I say the distance from P to A dash should be half the distance from P to A. So you draw in the 3 lines, and then you just make sure that PB dashed is half of PB, and so on for the 3 of them. Not too bad, I think. This one here, same kind of thing. The scale factor here is 1.5, so the image is going to be bigger than the object. So AC dashed must be 1.5 times AC. Again, we draw a line from the center of enlargement through every other vertex. And there it is there. I hope that's self-explanatory. Question 4, this is an area one here. Now, the key thing to remember about area, if the scale factor is K, that just relates to the sides of the shape. But if you're talking about how much the area is gone up by, if the side's gone up by a factor of scale factor of K, then the area is gone up by a factor of K squared. So again, have a careful look through that there and see how it goes. The last one here is kind of a sneaky question. The corresponding side to PR here is not TR. The corresponding side is TP. So when it comes to working out the scale factor, the original side here, PR, is 4. Then it's been scaled up by a factor of what? Well, this corresponding side here is 14. So, it's PT is the image and PR is the original, not 10 and 4. It's actually 14 divided by 4 is going to give you the scale factor. And then it goes on to ask you the length of ST then. Well, you multiply your 3 by 3.5 because the scale factor turns out to be 3.5. And again, the area. If the area of the original is 5, then the area of the image, that's the triangle PST, is going to be K squared times that. And then I think at the very end it asks you to find the area of the quadrilateral. So that's going to be the area of the big triangle minus the area of the small triangle. And again, I did stick up on Edmodo just some stuff, a summary of enlargements. So it kind of flew through it there. But again, same idea. Here the scale factor is 2. If you look here, if OB is whatever length, then OB dashed has to be double that. If the scale factor is 2. If the scale factor is 3, OB dash will be 3 times the length of OB. And then here's another example where the center of enlargement is part of the shape, but you just do the same thing. You draw a line from your center of enlargement through every other vertex. And if you notice here, BD is that length, then BD dashed has to be 3 times that length if the scale factor is 3. And then inside the object here again, it's a scale factor of 3.